Thank you very much, Stephen. I should probably start by just pointing out that my responsibilities end at 66,000 feet. That is the edge of controlled airspace, so any higher than that and you're on your own. That may change, of course, depending on where this all goes. So thank you very much for inviting me to give this lecture. It is a huge privilege standing up on this stage looking at some of those names. And my congratulations to the award winners and tonight's honorees of Professor Bohr and AVM Cousins. I think it is genuinely a privilege to be standing here. This is an event that's steeped in history. I will try and do it justice. I'm sure many leaders have come here at these kind of important times in the development of UK aviation. But it's hard to imagine a time that is more pressing, where it is more uncertain, more interesting, probably to put a positive spin on it, for our industry than those we face today. I'm going to talk this evening about some of those challenges as I see them, and the importance of the next few years to our industry. From my perspective, the UK has a fantastic, brilliant, strong, successful aviation history and aviation industry that I'm immensely proud to be part of. And it sits at the heart of our country's success as a trading nation. But we're facing a number of threats to that position, if you like. Our main hub airport is full. Others, as I'm sure we would be told if we had any airport representatives in the room, which we may well do, are close to full. Our current air traffic management approach for the volumes of traffic we're seeing is not sustainable, and our airspace needs to be redesigned, and I'm going to come back to that in quite some detail. And of course there's Brexit. Now I'm not going to focus on Brexit for this lecture, you'll be pleased to hear. I'm sure you've all had plenty of that morning, noon and night on the radio and TV. But the future framework of how we operate as an aviation industry is in question, and how we interact with our international partners is going to be a huge part of this. So for all these reasons combined, I think we're at an inflection point in the aviation history of the UK, a point where the decisions that we take now will shape our industry and the nation for decades to come. Decisions that are made for the next 5 years, next 10 years, about our future relationship with Europe, with our global partners, about our runway capacity, about modernising our airspace, managing noise on the ground, the impact of aviation overall. And of course about preparing the airspace for the future, just as Stephen mentioned, space, drones, autonomous vehicles. As a country, I think we have a choice at this point. We can face up to it and get on with the challenge, or we can do nothing and risk the industry stagnating, with delays growing, our economy suffering, and other countries leapfrogging us, particularly when it comes to hubs in a global aviation network. Or we can be pioneers. This seems like a good place to talk about pioneers to me. Pioneers in the industry shaping the way air traffic is managed and leading our industry into a generational leap that will give us the platform we need as a country to continue into the future. We've always been a country of aviation pioneers. It's why we're respected across the world in this domain, and it hasn't happened by accident. We're a trading nation. It is in our DNA to reach out across oceans from the times at which we ruled the waves, right till now in terms of how we actually get by with life. Geographically, we are brilliantly positioned. We are at the confluence of major intercontinental trading routes, and we've reaped the rewards from that. So this is just an illustration, just one day, and it kind of shows the UK's position from an aviation global network perspective. I always get a bit of a stunned silence after that one. These visualizations, some of you may have seen them. We've put quite a few of them on our website. That one will be available after today. You're the first people to see that one. They're available to download, to share with your friends and families and so on. I think it gives a sense of how we are connected, and it's that golden thread that connects us from an airspace perspective to every other part of the world. What we've done with those visualizations, and you can see a still for one of them here, this is one day over London. They've been a really successful way of trying to highlight and make the invisible visible. So the structure of our airspace and how it works and supports our aviation industry, without it, it simply wouldn't work at all. So our job from that perspective is to keep air traffic moving safely and efficiently. Safely is relatively easy if you have relatively few planes. If you have the number of planes that we have over our skies, it's a little less easy. Now, we're controlling about 80% of the transatlantic traffic. 80% of it goes through UK airspace. And we move about 8,000 planes a day, 2.5 million a year, 250 million passengers a year. And more than 99% of those flights are handled with no air traffic related delay. Now, you probably don't notice that, and we're very happy for you not to notice that. That's our job, to work away in the background. But it's no accident. We work tirelessly to make sure that's the case. But we are at a point where that same level of service in the future is going to become increasingly more difficult if we don't make changes now. And that's what I want to touch on next. The airspace that you saw there, and you can see here, was designed 50 years ago. And it served us pretty well, but it was designed for the likes of VC-10s, Vanguards, Tridents, planes that are in museums now. Since then, we've seen a 100-fold increase in aviation in the UK. No one, I think, when this airspace was put together, really dreamed of the fact that 2.5 million flights, 250 million passengers would pass through our airspace every year. And the current forecast, which may well be pessimistic rather than optimistic, show that reaching 3 million aircraft a year, 350 million passengers a year by 2030. So whilst the airspace has evolved and helped us manage the traffic, it hasn't really changed dramatically, and it won't support that rising demand that we're going to see in the next decade. If we don't change it, we're probably going to see delays 50 times what we currently do. So that's every flight delayed by half an hour, thereabouts. Airlines being effectively pouring huge amounts of money into delays, costing them over $1 billion a year. And obviously the impact on the wider economy is much greater than that. Now, actually, in reality, what will really happen is that we would see a breakdown in connectivity of those flights. So you would ultimately end up with it harming the aviation industry. The trade would simply go elsewhere. The airlines would put on aircraft to other hubs, and the business would go with it. So on top of that, we also have to renew our systems. They're effectively essential to manage that airspace. And they're currently in a position where they need renewing. They weren't designed for the era of big data, satellite-based navigation, real-time data exchange, drones, space planes, or for helping to manage the impact of our busy airspace on people on the ground. And that's something I'm going to talk a little bit about, because that's becoming an increasingly bigger problem. So the aviation industry, we've established, has changed beyond all recognition in the last 50 years, and the expectations have changed with it. The expectations of the travelling public, the expectations of airlines, airports, the expectations of local communities, and the expectations of politicians and governments. The European Commission set up something called the Single European Sky Programme about 10 years ago, with the intent of improving safety across Europe in the sky by a factor of 10, trebling airspace capacity, reducing the cost of air traffic management by 50%, and to reduce the impact on the environment of each flight by 10%. So a reasonable bunch of counterintuitive targets there, not easy to meet. So we had to find completely new ways of managing air traffic. Our airline customers, on the other hand, have spent a huge amount of money on new aircraft, and they've spent money on those aircraft with hugely impressive capabilities. They can navigate to a fraction of their wingspan. You know, they know where they are precisely in space and in time. But we don't use that yet on the ground. The regulations aren't there to support it, and we don't necessarily have the technology in place, and that's something that we're going to be fixing over the next few years. But it's not a single programme. It is a massive investment in time and money. And as I'm sure you all are aware, in a 24/7 safety critical operation, large-scale change isn't particularly easy. The one thing I have said to quite a few people when we upgrade our systems is that we don't get the option of the rail replacement bus service. It doesn't exist in our world. I wish it did, actually, quite frankly. It would make my life an awful lot easier. So one thing we've learned is we can't make these changes in isolation. We can't just decide to do it and get on with it. The kind of changes we're talking about here require effectively redesigning the airspace and the technology and transforming the way that we manage it require collaboration, open conversations, and a huge degree of political will. Everyone needs to be involved: government, airports, airlines, regulators, local authorities, community groups, GA, everybody to think about the bigger picture and actually work out what do we want from our airspace for our country. Try to build a consensus that everyone can get behind. And I think we need to start considering airspace as a national asset, because that's actually what it is. How do we make the best use of it as a nation? It isn't for one party, it isn't just for people going on holiday, it isn't just for GA, it isn't just for drones, it's for everybody. So airports will need to consider the wider impact of their networks as well as their own operational requirements, airlines the same. But to some extent, collaboration internally within the industry is relatively straightforward compared to the greater challenge, I think, with our community groups. This really gets to the heart of the role aviation has in our society: who benefits, who doesn't, and who gets to decide. Our airspace, we've already established, is critical to our infrastructure. One of the major challenges we now face is how do you have an infrastructure project modernisation that affects local communities? This is no different to an HS2. It's a huge challenge in terms of changing that airspace, finding the balance between a national imperative, this is airspace infrastructure that matters enormously to the UK, and local priorities. So there's resistance from communities to any change whatsoever, and our challenge is to find a way to address some of their concerns, because in modernising and redesigning our airspace, there's things we can do. We can have steeper descents, we can have steeper climbs. That moves noise away from the ground, reducing the footprints. We can change routes such that they are over less populated areas, or so that they have areas of times of respite, switching from route to route to route. These are things that the industry can do and probably needs to do to help here. But we also need to engage with those groups transparently and listen to their views. It's pretty clear from the number of complaints that I get from people overflown that communities suffering from noise want to understand more about the decisions that affect them when it comes to airspace, and they want to influence them, and that's entirely reasonable. We're increasing our efforts to do that, engaging with local communities earlier on in the process, just to make sure that actually everybody understands what it is we're trying to do, and how do you present something as complex as this in a way that people can really appreciate and understand and actually get to grips with. Well, if you change this here, there's a butterfly effect. You're changing something over here and something over there, and suddenly nothing's the same as it was before. So in return for trying to clarify things for the communities, we need to have a better idea from communities as to what good looks like for them. Now, that is a very tricky business indeed. As you start to talk to local communities, they all have an answer of where the flights should go, and it's pretty easy. It's anywhere but me. And they can all agree on that. Unfortunately, when you put it into practice, it doesn't really work. And it's human nature to want to be like that. And we see that from our politicians, we see it from local communities, we see it from everyone. And it's not surprising, but we need to balance that with the views of the passengers, the flying public, and the businesses that we have in this country that depend on the connectivity that we have, and deliver the best possible changes, the outcomes that we can to ensure our greater success as a nation. Now, we can't just think about today's airspace users, and Sir Stephen mentioned some earlier. We need to think about what this infrastructure is going to have to support. If you think about the fact that we're changing probably this airspace once in the next 7 years, and it will last another 30, 40, 50 years, what kind of users are we going to have in that timescale? We have enough problem with the capacity that we need to put on for the 3 million aircraft that are going to fly by 2030. And if I'd stood here 5 years ago and said the biggest problem we've got coming is drones, probably a lot of people would have said, well, yeah, it's not that big a deal. It's just, you know, some people flying some what we used to call radio-controlled planes around. It can't be that difficult to deal with. Now, actually, we're seeing safety reports on a pretty much daily basis. And that's just from hobby drones. That's before you get into the growth of drones that we're expecting to see around commercial implementations like agriculture, energy, and, dare I say it, passenger drones, which, you know, I'm pretty sure are coming. So when you think about the vehicles of the future and about how airspace will need to interact with them, and even beyond the wider aviation industry as to how we connect up all the modes of transport and putting the passenger at the heart of that. So I've got a little collection here of where this might go. So that's just a little taster of what we think might be coming. And it's a little bit science fiction-y, but probably not too much. As you look at these emerging trends, we're having to decide what technology we need to put in place to get ourselves an infrastructure that we can be proud of for the future and support the ambition of this country for literally decades to come. We can't afford to lose our place for the UK to have the opportunity to be at the forefront of some of these businesses, some of these new emerging industries. We need to really pioneer what it means to be an aviation nation in the 21st century, and that's not an easy thing to do. So, when we make these big decisions, prepare the landscape, what do we need to do within that? This is, it's all very well talking about the whole wider piece, but what do we need to do? Well, we're transforming the technology we use to manage our airspace, new tools, redesigning the airspace. I've mentioned that a couple of times already. We currently have probably what is the best air traffic organisation in the world. What we do, I'm not just saying that, you would expect me to say that hopefully, but actually the feedback we get from almost every returning pilot into the UK is that there are none better, which is fantastically gratifying. We deliver a safe, efficient, reliable service 24 hours a day, 365 days of the year, and we want to continue to do that, which means we need to change what we're doing. We're in the middle of a major investment. We're spending about $1 billion over the next 10 years to deliver essentially those goals that I read out earlier around the single European sky, so effectively tripling capacity, improving safety from an already fantastically impressive level to an even better level. And actually NATS has been leading that across Europe. And we're going to continue doing that irrespective of Brexit. It is our intent to continue to lead because we have to, because we have such constrained airspace. We have 11% of Europe's airspace and 25% of its traffic. So we have no choice but to change what we do. So what does it mean in practice? Well, I'll give you a couple of examples. So what we intend to have is that in the future at higher altitudes, not in the lower level congested airspace. So the sort of white shading you can see across the top here will be free airspace. So airlines will be free to plan their route depending on what suits them, not what suits us in terms of a road network. That enables them to follow the weather, enables them to take advantage of jet streams better. It allows them to prioritise what they feel they need to prioritise rather than us telling them how to actually fly. That saves them time, it saves them fuel, it saves them money, and it gives a better experience for the travelling public. To do that, we're putting in place a whole new service-based architecture for our technology. I'm not going to go into the technical details, but essentially what we're trying to have to avoid doing is re-engineering our systems on a 5-10 year basis in the way that we've had to do in the past. So we have set out from, for the last 20 years, we've been relying on systems that have been evolved and kind of plastered together, I guess, over years and years. And we're now making that wholesale upgrade that we need to in order to be able to move to a world that I've just shown you there. We're effectively putting in place tools that mean we can predict with far greater accuracy where aircraft are actually going to be. So at the moment, an aircraft knows exactly where it is, and its FMS, its flight management system, knows exactly where it's going to be. We can use that, connect it all together, share and receive data, and drive a much more efficient operation from the point at which you take off, whether your starting point be Singapore, Los Angeles, Hong Kong, Perth, whatever, and effectively know exactly what time you're going to arrive. In doing so, we can decongest the airspace, we can start to sequence things from the point at which they've take off, reducing fuel burn, improving noise, better managing that for local communities. Now, that's quite a challenge in its own right. It is one of the biggest transport infrastructure projects underway in the UK at the moment, and we have to do it, as I said before, while carrying on a 24-hour operation, which everyone takes for granted will run without disruption. So just to put that in context, I've described it in lots of different ways. We are trying to relay the M25 whilst using the M25. If we stop doing what we're doing, in 45 minutes, the baggage store at Heathrow is full and nobody can check in. So 45 minutes, an hour, I end up on TV for a very brief moment, and then things move on. So what you won't know, hopefully, is that we're actually in the middle of a transition at this very moment. So on Thursday of last week, we started transition terminal control, which does the lower level airspace, this really complicated bit here in the southeast of the UK. This is actually the busiest. We've just done a little bit of survey around the world. This is the busiest airspace in the world, the most complex, busiest airspace in the world. And we are moving it off of a fantastically impressive paper-based operation. You would not believe the amount of skill it takes to handle this on paper, which is what we currently do. Now, there are radar screens and everything else, but effectively the flight data is done on paper, and we're moving into the digital age, and we now have it as electronic strips. And we started doing that on Thursday, and I'm hoping, unless I see a show of hands, that nobody's noticed. And that's the way we want it to stay. Now, we're doing it very slowly, one sector at a time. We've got about 15 sectors to do over the course of the next 6 months. But what we do has to happen very carefully in conjunction with everything we're doing at the time. But that's, as I said, the tools themselves and the technology will only take us so far. What we won't do is reap the benefit of that if we don't change the airspace. Again, we have to make use of the technology that's available. So the fact these aircraft do know exactly where they are at any given time, they have the potential to revolutionise the way we're designing and managing our airspace. And I'm going to show you how in just a second. But essentially, with the new accuracy that we have with aircraft navigation, we can put aircraft much closer together, far more safely than we ever could in the past. So whilst that may sound slightly frightening, actually, if you think about it in the past, we kept aircraft separated with radar, and the radars were accurate to a certain amount and the aircraft were accurate to a certain amount, so a preset distance was put in to say, well, if that's wrong by that much and that's wrong by that much, we still know that they're not too close together. Now we know what they are to within 30 centimetres, so actually those routes can come together with a far greater degree of safety than we've ever had before. So we plan to use that, and it's something called performance-based navigation. The pilots in the room will probably have heard of it, but I'm just going to show you how we're going to use that.
To meet this increased demand, keep flights on time, and most importantly, keep them safe, we need to modernise our airspace, taking advantage of new technologies that give us more options in how we use it. The way we use UK airspace hasn't changed for 50 years, and aircraft are still required to fly via ground-based navigation beacons. Modern aircraft are capable of performing so much better than our existing airspace and air traffic control procedures allow, and can fly very precisely using satellite guidance technology. All of us are familiar with sat-nav, but on aircraft we've not been able to use it to its full potential up till now. Modernised airspace and new procedures based on this navigation capability open up much better options for how we manage air traffic. Aircraft will no longer have to fly over ground-based beacons or be given tactical radar headings by air traffic controllers to ensure safe separation. What enables this is performance-based navigation, PBN. This sat-nav for the skies means aircraft fly much more accurately, giving us scope to design more routes and for aircraft to fly in a different way. In the future, airlines will be free to plan their own routes and trajectories above around 30,000 feet. Below that, they'll fly in a zone of systemised airspace where their routing is strictly defined. Inbound aircraft will enter the systemised airspace via gateways and use a series of PBN tracks, tubes in the sky, towards agreed final approach routes, removing vertical holding stacks and reducing noise and fuel burn. At lower levels, a balance will have to be struck between capacity and environmental considerations, especially noise, on both arrivals and departures. On departures, this means more routes can be accommodated in the same airspace as before, which means they can be alternated to provide predictable respite at lower levels. A departing aircraft will climb continuously towards a letterbox on its route. This acts as a transition point from the airspace associated with a single airport into the wider systemised airspace with multiple PBN tubes. Aircraft then pass through the letterboxes and out on predefined PBN routes up towards free route airspace. This all means we can transform our airspace, free from the design constraints of the past, and creating new possibilities to increase capacity safely. At the same time, it opens up new ways to mitigate the impact of noise on local communities. It doesn't mean aircraft won't fly over populated areas or that our lives will be noise-free. We'll continue to see flights overhead simply because we have busy major airports in the UK, especially in the southeast. Routes into and out of these airports will still crisscross our skies, but in a much more structured and predictable way. These changes will vastly reduce the amount of tactical intervention by controllers, make routes far more predictable and more efficient. It'll increase capacity, enhance safety, and improve environmental performance, giving the UK the airspace it needs for the future.
Hopefully that gives you a little bit of a sense of how we plan to re-engineer the sky. I think, interestingly, that video we have to do as a cartoon, because if you put a map underneath it, we start to get complaints about where the planes are flying. And considering those planes are about the size of a county, it's pretty hard to tell. But it sort of gives you a sense of the amount of scrutiny that any change to flight paths, particularly below about 10,000 feet, really gives you. Now, there's one thing that was mentioned there that I haven't really picked up on, which is safety. And the idea of doing this is it has a massive benefit for safety. At the moment, we have something in the region of 1,000, 1,200 controllers who spend most of their days saying turn left, turn right, climb and descend. And actually, in this world of predetermined routes, predetermined deconflictions, actually they will be there to manage the exceptions rather than delivering the service on a daily basis, and that is far safer. Every time we give a command to an aircraft, there is a risk that the command is wrong, that it's heard wrong, that it's read back wrong, that it's listened to wrong after the read back, and so on. So it's hugely improving safety as well. Now, we'll reduce the need for stacks, which I'm sure will please many people. The idea of going around in circles over London after a long flight or a short flight is never much fun. So making just much better use of the airspace in general. It also offers, as was mentioned there, predictable respite. So this is the ability to switch routes on and off on a daily basis, hourly basis, weekly basis, to rotate around what communities get noise and what don't. Now, there's a risk in that to some extent, that some people will now get noise they never got before. But having said that, there's now a more fair distribution. So the choice becomes one of, is new noise, if you haven't had it, worse than less old noise if you did have it? And you start to see how it gets politically quite challenging. So if we can deliver all this, well, what does the world look like? How would it feel? It will be nothing short, from my perspective, as to a revolution as to how we plan and manage our airspace. So the way we've described it is that air traffic will be managed according to a single comprehensive organisational plan that covers all the airports in the UK and extends across international boundaries. The plan's developed a year in advance, and it's updated on a monthly, weekly, daily, minute-by-minute basis, facilitated by real-time data exchange between all the parties. Any instance that have the possibility of derailing the safe, smooth operation of the plan is collaboratively managed across all the stakeholders to deliver the best result for the travelling public. And with better data exchange comes the confidence that you will actually arrive at your destination at the time you hope to arrive, and depart when you expect to depart, although the latter doesn't matter so much, but we get very fixated on it. With effectively greater flexibility comes less disruption, resources better assigned to the tasks they need to be deployed for, and where they needed to meet demand. And then with greater precision and knowledge of where every aircraft is, and I'm talking really about total conspicuity here, there's an opportunity to cope with the types of volumes and new users that we've been talking about over the course of this last half an hour. So commercial, recreational, large and small, manned and dare I say it, unmanned. And this model can expand beyond aviation. This becomes a integrated, cross-modal, intelligent transportation system of the future, not just connecting the aviation industry, but also connecting the wider modes of transport, providing passengers with genuine end-to-end journeys and certainty, not just the flight piece. And I think that means the UK will be in a position to be ready to cope with the future demand that we're likely to see, to safely meet that growing demand and the growing traffic, to optimise that shared asset that effectively is our airspace. Now, to conclude, as I said at the start, we have a bit of a choice here about how we face up to the challenges that lie ahead of us. We can be followers, passengers, if you like, or we can be pilots, pioneering in shaping the way we manage air traffic and leading our industry on a generational leap into the future. The benefits are hard to overestimate. The UK's aviation industry, as you saw from that first video, has been crucial to this country's success for decades, and its importance I can only see growing in a post-Brexit world as we seek to build further ties further and further afield, both airport stays the same in this world. So if you think about some of the drone activities and some of the thinking about drones, it is more going to be short journeys between airports you might make to the local airport in a drone, in which case actually you might do more direct flights from a single point to point rather than hubbing through a major airport. So it's not clear which direction some of that's going in. So I think the idea of building a new airport to cater for a future that's a little bit harder to see is probably a bigger challenge. Now, I'm not a politician. Personally, as far as I'm concerned, the more runways we had, the easier this problem would become in many ways. But given how long it takes to build a new runway or not, the idea of building a new airport, which would have to have at least 3 or 4 runways, I think it strikes me as just unlikely in the current political climate, even if it was affordable. My preference would be to see more capacity at every airport, and obviously with all due respect to people who are overflown, clearly we need to manage that, but I think the more capacity we can add across the whole network, the better.
Thank you very much indeed, Howard Wielden. I'm very, very interested in this. I think it's absolutely fascinating what you're planning to do for the future. Can you just talk me through what the particular training aspects are in this change? Because there's a lot of pilots, there's a lot of different airlines from all over the world coming into the UK and going out of the UK.
Yep. So that's actually a big part of the challenge of this. So we phased in, so we won't do the whole airspace in one go, but you do have to do it in quite a lot of sequential chunks in a relatively short space of time. So the way it will work is that all of the airspace designs that we come up with go through a fairly robust procedure with almost all of the airlines that fly into and out of the UK. They all get published on a particular cycle, well scheduled in advance, in fact actually often up to a couple of years in advance, and the new process we have now, which also allows for community engagement, will mean that that's probably even longer. So essentially there's plenty of time in there for the individual airlines and pilots to train on the new airspace. They all get sent out as part of an AIRAC cycle. Some of you may be familiar with that, but it's effectively a worldwide change of aeronautical data on a 28-day cycle. These will probably occur on a yearly basis. Well, we're talking really about change starting now, but on a relatively small scale, through to about 2026. So it'll be about 7 or 8 years of major change. The biggest part's happening in about 23, 24, 25, 26. But there will be plenty of time in there because we have to train. One of the challenges of this, actually, from an airspace perspective, is everything has to happen the same night. So it isn't like technical changes where you can perhaps schedule a technical change that nobody notices. The pilots that are taking off, in fact, in many cases, the pilots that are airborne have to know that when they arrive at the UK FIR boundary, they're about to see a different airspace to the one they saw on their charts before they took off. So it is a phenomenally complicated process to arrange, but it's part of that process. So plenty of training. In fact, the biggest problem with a lot of this is getting it into operation. The design, challenging though it is relatively straightforward compared to the transition to operation.
Perhaps there won't be any pilots by the time the transition.
Maybe not. Maybe not.
Sorry, Simon, just in the red tie.
Good evening. Scott Pendry from the Aerospace Technology Institute and also the Air League. My question is about urban air mobility. It's something that is really concerning us in positive and negative ways in work. We're doing a lot of thinking about it. To what extent are you thinking about it in NATS? I'm talking about airspace perhaps below 1,500 feet, sort of that band between 500 and 1,500 feet.
So actually, we have in the last 6 months to a year maybe, started to think about airspace in a wholly new way, and many of you who are pilots will know that we have different classes of airspace. So there's controlled airspace, Class G airspace, and so on. And some of what you're talking about there will be Class G airspace, but not everywhere because it's quite complicated. I actually think, and this is sort of my view and the emerging view within NATS, that actually where we're heading here is to a single class of airspace. And that single class of airspace will effectively be open to every user, depending on how they're equipped, and as long as they play by the rules. Because I don't see any other way of doing it. If you don't do that, then I think this is where you're getting to in terms of the concerns, you run the risk of dividing the airspace up into smaller and smaller chunks, and you say, GA can play here, but the best you're going to do is get airborne, do a circuit, and land. You can go and fly your drone in this field, but don't you dare leave it. And if you're if you're running an energy network, you can't fly it over the pylons. And if you want to get a drone to your local airport and land there rather than park your car in a car park, by the way, destroying the airport business model, then so there's some interesting challenges in all this, then you have to reimagine that whole airspace. So I think it's one single class of airspace. And it's all about best equipped, best served, so you get to do more if you abide by the rules and have more capability.
Thank you for a really insightful talk. I was really struck by the complexity, but you did refer to the butterfly wings effect. To what extent are you contingent to fully realise the potential of this, of changes occurring elsewhere as well?
So this becomes a question of 80-20, I think. So I think that if it's an interconnected aviation network. So to some extent, you are reliant on the entire network to get the best changes, or to get the best out of any changes. I think what we've concluded, though, is that if we do the changes that are specific to the UK and the North Atlantic, then we get probably 80% of the benefits in terms of capacity, 80% of the benefits in terms of safety and so on. Where it gets very difficult is, and it's probably easier in the UK because of the nature of the traffic that flies over it, where it gets very difficult is in mixed equipage. So it's not so much the equipage on the ground and the stuff we're talking about here, it's more the airborne equipage. So if we were, for example, having a lot of different types of aircraft with, some with effectively modern navigational capabilities and some without, and each of the airports had a mixed fleet, that would become much more difficult to gain those synergies, if you like. But I think we're sort of in the 80-20 range. But there's no doubt that if you want to do that, if you want to do what I said from Hong Kong, if you want to sequence the flight that's just left Hong Kong or just leaving Hong Kong tonight to arrive tomorrow morning with the flight that's just leaving Los Angeles, and actually decide now what order they're coming into Heathrow, and they're going to be something like 90 seconds apart, then there's a lot that needs to happen in that chain.
Get rid of the passengers.
That's right.
Martin Broadhurst from the Society. As you increase the technology applied in the systems you talked about, the surface that you create for cyber attack grows. Yeah. To what extent is your effort focused in making sure that we have very, very robust systems?
You'd expect me to say that cyber is one of our big focus. Actually, interestingly, air traffic in the past has largely been air gap, so the systems haven't really had connectivity to the internet. Most of the systems, we actually use a term called security through obscurity. You don't get many jovial programming language hackers at the moment, so because these are languages that are so old in many cases that actually there's nobody out there looking to try and ways to break them. Literally the entire world supply of jovial programmers, I think, work for us. So at the moment we've had this obscurity piece, we've had this air gap piece where we're not really connected to the wider sort of Internet of Things, or the Internet at all, in fact. The world we're moving to is absolutely way more connected. And part of that technology refresh is to put in place from the very start those security aspects that you would expect to be present in any modern system. So actually an awful lot of what we're designing in now is that security from the start. So it is all about how we design the new system from the ground up. So it'll include things like proper security operations centres where we effectively have the ability to monitor real-time what's happening on all the networks. So no different to any other safety critical piece of infrastructure in that respect. But it's sort of an interesting one in some ways because we still have to figure out to a degree where the risk is, because the thing to bear in mind in all this is that at the moment at least the end output of all of this is a plain voice transmission through the air. So if you really want to disrupt this network, then a jammer somewhere in Uxbridge will do the trick. Now that's clearly not an idea that we would want, but effectively you kind of have to judge the risks that you're facing, and I think that the airports are probably a major focus of that, but it's absolutely one of our top things to bear in mind with the technology change.
Hi, Martin, commentary from the Society. You've intimated the benign aspects and the way the future could hold some interesting things. I'm not just talking about Amazon for drones. What about the threats to your major airports from drones? We've seen some clear examples of near misses. There is a view in some quarters that these are only flimsy structures, but I seem to recall that the lithium battery going down your engine or hitting a secondary flying control surface or going to the cockpit can really wreck your day. What are you doing in terms of protecting, detecting, And it's all very well having regulations for little Johnny who receives one at Christmas, but I seem to recall that Daesh and others are not really interested in regulations where it comes to protecting airliners and the like.
So it's a massive worry. I think we split it up into sort of three groups really. So the first group is your professional, well-trained drone user. So this will be a commercial user that's done all the right training, that they tend to, they'll be the ones that are using it for surveying or whatever. And actually we worry relatively little about those because they're there for a commercial purpose and they tend to want to follow the rules for their own insurance purposes. You then have the enthusiastic hobbyist who perhaps isn't aware of the rules and is going to end up flying in an area where they shouldn't. We are trying to combat that in a number of ways. Part of that is working with various establishments to look at how do you actually detect drones, and then when you detect drones, what do you actually do? Because I don't doubt for a minute that actually if you have a system in place that detects them, you then have to do something. It's not really much use detecting them and then saying what now. And there's a little bit, I think, I sense a little bit of an uncertainty around the world with regards to airports and drones, in that nobody really wants to be the first to detect them because they then have to decide, so do you shut the airport every time you detect a drone? Or do you carry on as though it's like a bird and perhaps continue but with observations that actually it might be like bird strike? I think it depends on the size of the drone. So I think actually being able to categorise what is likely to cause damage above a bad bird strike. I think you also have to be in a position where there are far more ways in which to track down drone users, and I think more enforcement is clearly going to play a part in this. If you come to the so then the other thing, so the one thing that we're working with the manufacturers with quite closely is on the idea of geofencing. So effectively a drone that will not operate in certain areas, so it knows where it is, it uses the GPS on board, or uses a GPS on board to work out where it is. If it's inside an area where it shouldn't be, then it won't operate. Now that's fine for the hobbyist who might make a mistake. Clearly that's not going to make a difference to the terrorist, who I'm sure is going to be able to overcome that. We did a lot of work over the course of the Olympics with the military on drone attacks, as you would expect. And I think it's probably fair to say at this point in time it's pretty much an unknown science. There are quite a lot of systems out there that can start to detect them. I'm not sure of many that can reliably stop them. There are ways, obviously, to jam them, but obviously you've then got that risk of you don't really want to be doing a lot of jamming around a lot of sensitive other equipment that's going to need to be controlled. So there's no easy answer to that one, but it is something that the entire industry is pretty alive to at the moment. There's a lot of work going on in whether it be Eurocontrol, whether it be with us, with a lot of the research establishments as to what to do next.
So you're not a protagonist of using a squadron of Harris Hawks?
Do you know what? I'm actually with the. I'm part of the camp that says whatever it takes. I think if there's a role for buzzards on the airfield, then that works for me. But I do think it's a difficult one to solve, and I think not least of which is the what do you do when you spot them? Exactly that.
Hello, Robert Marshall from the Society. In the past, the responsibility for safety and separation was always with the pilot, ultimately. Mm-hmm. And as the airways get more and more complex, one can see a sort of a transition of the responsibilities for safety going from the pilot to the air traffic controller. And one can see that sort of happening however the sort of legislation works. And when do you ultimately say that when the responsibility does go to the air traffic control within those controlled airspaces, that actually a machine is rather better at sorting out the conflictions than people? We've talked about pilotless aircraft. Yep. And when do we start talking about air traffic controllerless air traffic control?
Yeah, that's a very, very, very fair point. I mean, I was having this debate earlier today, actually, with some of our folks. Actually, if you look at, this is no different to aircraft in many ways, but if you look at the vast majority of safety incidents, they are human error in one form or another. I have lots of debates where we sit down and we say, how did this happen? And we go through the entire logic of the sequence, and it includes what happened in the cockpit, what happens with the controller, and at the end you conclude that somebody in that sequence missed a warning. The systems knew there was something wrong. They pointed it out. They probably pointed it out more than once with an increasing sense of urgency, but somehow the individual fail to notice it for lots of good reasons when you delve into the human performance piece. So then we have a debate about, okay, so how do we make them really take notice of it? What do we need to do differently? And actually, I think we are getting to the stage now of saying there are circumstances where what you do differently is you take them out of the loop. Now, I think the way it will evolve is the way the cockpit has evolved to a large degree, which is that air traffic will become much more about dealing with exceptions rather than dealing with routine. And I sort of alluded to that in parts of my speech. Essentially, if you have deconflicted ahead of time the major flows of traffic coming into the major airports coming into the country, then you have the ability to effectively just let that run entirely as planned without any interaction. Effectively, the flight plan gets uploaded to the FMS. We've got the same flight plan that the FMS has got, so the aircraft is going to fly what the FMS tells it to. The air traffic control system knows that. As long as you have some degree of conformance monitoring, then you're fine. And it will only be when that aircraft has a mechanical failure or whatever that you actually start to intervene from a controller perspective. That's much like on a modern aircraft now, where it's more about systems management. The difficulty with that is you then run the risk of, does the job get very boring? Are you just monitoring? And monitoring is hard for humans. That's probably worse than excitement in many ways. So I think forms of AI are going to start to play an increasingly important role in all of this. And just as a little bit extra there, we actually had Google DeepMind in talking to us a few weeks ago. What was really interesting about that was they were looking at it and saying, this is a fantastic problem to look at solving because it's so complicated, because you use machine learning in that sense to do it. But then they talked about the fact that one of the problems they've got is they had to develop software to scan their bots, I think they're called bots, to scan their bots to make sure that the bots haven't finished solving the problem and moved on to something else, because they get bored and go and do something else. So you kind of move into a strange new world which has the sort of a lot of the same effects. But I think you're right that ultimately there will be less direct human intervention on a minute by minute basis.
Hi, Andrew Neely, Australian Division. Given that you're transitioning reliance from, say, ground-based radar more and more to people knowing where they are via GPS, what contingency do you leave in place in case of GPS failure, environmental failure, or deliberate denial?
So I think that for the most part, at least to start with, at least for now, we will continue with effectively secondary surveillance at least. So that's effectively picking up transponders, the transponder codes that at least 95% of aircraft actually fly with switched on. And actually, can I make a call to anybody in the audience who's a GA pilot? Please switch your transponder on. It makes our job so much easier. That's the only plea I'll make on that one. So we'll have a network. We'll still have continue to have a network of that. I think we'll have a network of ADSB, whether that be space-based ADSB. So this is automatic dependent surveillance broadcast, which is effectively the planes talking to each other and talking to the networks. So I think those two will exist. I think the one that's in doubt for me is primary radar. I think the only reason in the next 5 years for primary radar will be for non-cooperative targets. So effectively that will be things of interest from a military perspective or from a policing perspective. I think the question will have to be one of, do we need those for those purposes, and therefore that's a reason to have that network so you have a further backup, or are you in a position where you don't need that except in specific places? I think the jury's still out a bit on that. But I think we'll still have to have at least 2 levels of redundancy in there.
Simon. Simon Wally, Royal Aeronautical Society. Do you think the government's plans and proposals to improve decision-making, speed up decision-making in airspace change go far enough to support modernisation?
So we've been very involved with all of the work that the government's been doing. I guess where I would start with this is that 5 years ago we tried to do this and we singularly failed. There wasn't the political will to change airspace. Once you get to moving tracks on the ground and people getting very upset about it, you end up in a situation where it's very, very difficult to make any progress. Since then, we started a campaign with airlines, with airports, called The Sky's the Limit. And it was really around the problems that I've outlined here, effectively, which is that the airspace is full and something needs to change. Since then, we've had pretty good government support. So I think that's where all this starts. Effectively getting this through, much like HS2 or anything else, is to treat it as an infrastructure project. It has been recognised by the National Infrastructure Committee, I forget their name exactly, but you know what I mean, the one that's run by Lord Adonis. So it's been recognised by them as a major part of delivering new airport infrastructure. You then have the airspace change process itself, which is associated with the government policy which is being consulted on. I think that whilst it's probably harder now to get through and probably takes longer, my hope is it's much more certain. So in the past, if you got to the end of it, there would be, without a doubt, there would be a judicial review, and then it would all be thrown up in the air and you go back to the start. With this, it's far clearer as to each step where you can say, okay, we're done on this, and even if there's a challenge from this point, we only go back this far. So I think there's more certainty in the new process. It only comes into effect on the 2nd of January next year. So I mean, to some extent, we're going to have to try it to know for sure. But my sense is there's a desire both from the CAA and from government to make it far more predictable. The big challenge for me is the government still to some extent debating around concentration versus dispersion of noise, because words like concentration where appropriate but with due accord or due regard to dispersion isn't very helpful. But I think they understand the problem, and it becomes concentration makes a lot of sense. You put it over quiet areas where there's no people living, but then it turns out that people do live there and it's quiet, so they can really hear the planes. So it will be hard, but I think it's better than it was. Yeah, one's good.
Right. Peter Norris, past president of the Society. Thank you very much, Martin, for a stimulating question. But before your brave new world arrives, the stress level on your controllers is going to go from extreme to severe, etc., etc. Can you say something about how you're handling that, mental health issues and so on and so forth?
Yeah, it's, that's something that we are very large. So the first thing we try to do is select the right attributes. So right from the point of people applying for the job, we do try to make sure, to the extent that you possibly can, that they are well suited for the job. And it is all around aptitude, at least at the moment it's all around aptitude, because that ability to take that picture and turn it into 3 dimensions. Once they're then qualified, and actually just to be clear, we get about 16,000 applicants every year and about 50 of them end up as controllers, so it's a very, very wide pipe at the top for a very small number at the bottom. And those people are naturally relatively resilient, but that doesn't mean so you can take that for granted, clearly. We have a lot of well-being steps within, effectively formally within the process, so there's lots of rules around what, actually legal rules around how many hours can be worked, how long before a break. So most controllers in the UK can only, depending on the business of the airspace, work for an hour and a half before having a 30-minute responsibility-free break. We have trained CISM controllers, so critical incident stress management people trained in critical incident stress management who are actually controllers. So they are there to effectively give somebody to talk to if a controller's either had an incident or just had a bad day and needs to talk to someone. We've also started a massive wellness campaign across the whole company. When we started to look at safety, we've got a value which is safe in everything we do, and obviously the advancing aviation, keeping the skies safe, safe appears in pretty much everything we do, as you would expect. And we suddenly realised that safe in everything you do means looking after the individuals and their mental and physical well-being as well. So we've actually started doing things like running mindfulness classes. Might sound somewhat sort of different to, to what you might have expected, but actually making sure people have the right level of breaks so they can clear their mind, that they can talk about it if they've got problems, and actually kind of just raising the issue that mental health is something that's out there and people shouldn't be afraid to talk about it. I was talking to someone the other day who actually had suffered from some mental health issues and said that the fact that we are talking about it now as a company means that everybody is better equipped to deal with it, because nobody feels as embarrassed to talk about it as perhaps they might have done. So it is a massive issue, and it's one that really got sparked by the Germanwings incident. That's where it started for us. We took a far greater look at that. We're also recruiting more controllers just to deal with the numbers as well. So it's two sides.
Anyone? Oh. Okay. First here.
David Grove, retired air traffic controller. How do you view the...
Oh, no. I knew this would happen at some point.
How do you view the integration of military flying into the free route system that you propose for the future?
So we sort of have it already in some way, I would say. If I look at the joint and integrated system and operation that we run at Swanwick at the moment, Swanwick is our main operating centre for everywhere south of Manchester. If you look at the way the military controllers operate there, they are part of the team and they effectively coordinate the military traffic on a free route basis through the other aircraft. So where I would imagine that would, and they use the same tools and largely the same tools and the same systems. So my expectation is that there will be additional tools required. But that free route airspace doesn't mean you just go where you like. What it means is you file and